Okay, this video is particularly on Chebychev's theorem. It's actually a Russian name, so you can call it however you you can pronounce it however you think it should be pronounced. But I've had several students have questions about how to work these types of problems. So on my question 3.3.26, assume the average selling price for houses in a certain county is 337,000 and a standard deviation of 39,000. Using Chebychev's theorem, determine the range of prices that includes at least 88% of the homes around the mean. So the first formula I have is actually the formula for Chebychev's theorem, but we need to change this. We're trying to find Z, and we have the percentage of the percentage of homes around the mean. We already have that percentage, so we're kind of working backwards here. So you can use a little bit of algebra to solve this for Z, but I don't want to get into that. So just to avoid confusion, you can just use the formula where it's solved for Z, and I think that this will be better just to go ahead and have the formula solved for Z when you're using, if you're given the percent. So the way we do that is we do the square root of 1, and we're going to change 88% to 0.88. So be sure to do that. Change it to a decimal. And then here is the formula that you will use that is already solved for Z. So what we get here is Z equals the square root of 1 over basically 0.12. So what you want to do is you want to do 1 divided by 0.12 and take the square root. Now, anytime you take the square root of a number, you're going to have that number positive and that number negative. Let me put this in the calculator. Okay, so we should have 1 divided by 0.12, and the square root of that would be a decimal, a long decimal. If you look on view an example and go through the example on the MyLab homework, you will see that when they did the Z-score here, they rounded to the third decimal place. So if you didn't do that, that may be where the issue is. So if you round to the third decimal place here, you would get 2.887. So 88% of the homes, that would mean a Z-score of about 2.887. And that is positive and negative. Now what we have to do is we have to calculate the values of the maximum and the minimum here for that particular, the upper bound and the lower bound. So let me fix that. All right, so what we'll do here is we'll do X equals the mean plus the Z-score times the standard deviation. So we know that the mean, mu is the mean, the population mean is 337,000 plus and minus the Z-score of 2.887 times your standard deviation, which is 39,000. So first we'll do the lower, well, they did the upper first, so we'll do the upper first. So do 337,000 plus 2.887 times 39,000, and you should get, if we round to the nearest dollar, you should get 453,220 for your upper bound. Now for your lower bound, okay, hold on. That may have been my first number. Let me make sure. Let me put that in the calculator because I rounded to the second decimal place at first. Then I realized they wanted me to round to the third decimal place. 2.887 times 39,000. Okay, so that is 449 and $1,593. We're rounding to the nearest dollar. Now for our lower bound, we're going to do 337,000 minus 2.887 times 39,000, and we get 224,407 for our lower bound. Okay, and that's what I've got here. So let me just highlight something real quick. Rounding is very important on the homework, and if you don't have it rounded exactly right, you'll miss it. So how did I know to round to the third decimal place on that part? Well, I'm going to keep hitting continue until I get to part D. Okay, so here's part D, and if you notice here, when I get my Z value, it says in the example to round to 3 decimal places. So that is how I knew that my calculation for Z should be rounded to 3 decimal places. So you might want to view an example. If you get it wrong the first time, it's probably going to be due to rounding. But that is how you work part D on this problem. Please let me know if you have any questions.